experience is from the talks yesterday too. So like any other experienced engineer, I headed to Google, but then I remembered it's 2023, so ChatGPT. So we're going to ask, OK, how do I implement dark mode with React Native? And it's going to say a bunch of stuff, output some kind of interesting code with like style sheets and the render function. But the point is, if you look at ChatGPT or the top 5, 10 tutorials from Google, what you'll end up with is probably something like this. So we're going to start off by using the use color scheme hook from React Native, so figure out what mode the user is in on their phone. Then we might do some logic to figure out what colors to use based on the color scheme setting. And then we're going to use the style sheet APIs to set our views, text, or whatever components with those colors. And this is a totally fine approach, especially with newer, smaller code bases. But as we started to look at our code base, which is over 4 years old and has hundreds and hundreds of components and screens, we started to see a few problems with this approach. So today I'm going to cover 3 different problems that we saw with this approach when we tried to implement dark mode at scale. And hopefully this kind of turns into some insights that you can take home with you. So the first problem here is using the system setting directly. Now, if you've used any app that supports dark mode, you probably have seen that most apps implement an app-level theme override. So this is nice because you kind of allow the users to have their own preference. So maybe they have dark mode in their system, and then they want your specific app to be in light mode or vice versa. So this is kind of just like expected user experience at this point. But there's actually one other reason why this is super important, and that's to do with feature flagging. So at Chime, and like in many other larger companies, we practice trunk-based development. This means that developers are often integrating their changes into the main branch, and we use feature flags to roll out features instead of the mobile release. By having an app-level theme override, we're able to put the theme switcher behind a feature flag and force all of our public users to be on light mode while we're still working to kind of finish and polish dark mode internally. No single developer or team can possibly implement dark mode in one go at our scale. So this allows us to kind of federate the responsibilities out to different product teams so that they can go and check out dark mode in their own feature and maybe even submit bugs or commit fixes to it. So doing this does require writing some native code right now, but in React Native 72, there should be a new API that comes that will allow you to override the color scheme at an app level. So looking forward to that. So that's problem number 1. Let's take a look at number 2, and that's not using color tokens. Now this isn't dark mode specific, and if you've worked with a larger code base or with design systems, you've probably already done this. It's a great idea to, instead of using hard-coded color hex values, using color tokens instead. So these are like naming your colors and referring to them by reference. We're going to recommend going one step further and using usage-based token names. So what does this mean? It means instead of using token names like dark green or light gray, name those colors based on usage, like border primary or content secondary. There's a few perks about doing this. So one of them is that the same color can have multiple tokens. Now you might be thinking, why would I even want that? There are 2 main reasons. One is maybe a border shares the same color as some text. But maybe in the future, with the redesign, you might want to change them into different colors depending on what the new design looks like. Oops, sorry. And the second one is that if you map colors into dark mode, you might want to actually map different usages to different colors, even though they're the same color within light mode. So that's going to be really handy to have when transitioning to dark mode. And now let's look at the third problem. The third one is around modifying render logic. So this kind of approach requires us to go into the render function, actually change the logic to take into account of dark mode. Now, what do I mean by this? At Chime, we still use the style sheet API. There's nothing wrong with it. It works really well for us. We are moving towards more centralized design system components that take in kind of styles as props. But we still have like over 1,000 places in the code base where we're setting colors into our styles. What that means is if you look at this example of like a sample component, we have hundreds of components that look like this. We have a view where the container has a background color and then maybe some other styles in it, like flex1. If we were to adopt the kind of traditional approach, we would have to do quite a refactor. We have to add in a hook of some sort. We then have to figure out what color we should use. And then we also had to do this thing where we had to figure out that the background color is something that we're now going to apply with inline styles, and then we have to like leave the rest of the styles in the style sheet. And for a more complex component, this can be a pretty kind of difficult migration. Definitely not something that we can easily implement using a code mod. And last of all, we actually still have a lot of class components, so we wouldn't even be able to use the hook. We would have to use a higher order component, mess with the prop types and things like that. Kind of annoying. And yes, there are other solutions out there that help with dynamic styles, like styled components is really cool, but it still kind of requires changing that logic to be dependent on props, and we don't use styled components. So at this point, we were a little disappointed. We didn't really want to embark on this large migration that involves touching a lot of components. And we also didn't really want to modify a bunch of components and make the render logic more complex when they're actually simple components. So just when we thought we couldn't get those 2 stars back, we found an API called Platform Color. Now, what is Platform Color? Platform Color was actually introduced in React Native 63, so quite a few versions ago. It was primarily introduced for hybrid apps. So if you had a native app that already had a bunch of colors defined natively, if you added a React Native view in there, you can actually use Platform Color to hook into those colors, and then you wouldn't have to kind of copy your colors into the JavaScript world or keep them in sync. But it turns out that this API fully supports themes, or at least it eventually did after a bunch of bug fixes. And if you look at the Platform Color documentation in the React Native docs, you won't really see anything about dark mode except for this sentence that says, since native colors can be sensitive to themes, this platform-specific logic also translates inside your components. And that means that we can use it to build dark mode. Funny aside is that if you look at the React Native documentation, React Native for Windows and Mac OS, there's actually a pretty great write-up about how to use Platform Color to respond to themes. So definitely check that out. So how do we go about using Platform Color within the Chime app? We don't have a hybrid app. We're 100% built on React Native, so we don't have any colors defined within native. Luckily for us, we found a great package from Klarna called Platform Colors. So all we had to do is define a colors.js config file. We simply listed all of the colors that we had in our app, the tokens and their light and dark mode values, and a bunch of configuration for where to output these files. And then we ran yarn platform colors, which is the package strip that came with the package. And it generated a bunch of stuff for us. So it started off with generating an entry point so these are the color objects, if you will, that we will import from our components. Then it generated iOS and Android TypeScript or JavaScript files. And this is actually the one and only place that we are calling the Platform Color API from React Native. And each of these color values are actually objects that are references to specific colors. And they're kind of never resolved in the JavaScript layer. So JavaScript has no idea what these colors are. It's only resolved in the native layer. And of course, we have the native colors that get generated too, like XML on the Android side and Xcode assets on the iOS side. And because we already had all of our colors tokenized, even by usage, bonus points for that, we could just switch out these hex values for these platform color objects. And then if we go back to that example we had, let's see what it takes to make this component dark mode sensitive with platform colors. That's right, no modifications were needed. So this was the case for 99% of our components, which was really, really compelling for us. But of course, there's always that 1%. So we just fell back to the normal kind of hook-based approach where we do modify render logic. And this kind of mostly happened with third-party views that might not support platform color out of the box, or things like animations with like color interpolations. Those, we kind of needed those hex values, so we just kind of took the traditional approach, and there was nothing wrong with that. So let's take a look at what dark mode might look like. Doesn't that look great? There's something about seeing the app that you work on regularly in dark mode for the first time. It just looks so cool. And I don't know if you've noticed that transition earlier. It wasn't a keynote animation. This transition from dark mode to light mode and back is actually recorded straight from the iOS simulator. Because the colors are completely handled on the native layer, iOS is able to smoothly transition between light and dark mode without needing for any React re-renders and so forth. So we have this really nice animation on iOS. I know, it's not quite as impressive as the Skia one, but I'll take it. So why did we choose platform color at Chime? We got dark mode pretty much for free for most of our components. It was a hybrid solution, so we were still able to fall back to the more traditional hooks-based approach for the components that didn't work with platform color. And because using platform color required us to set the color scheme at the native layer, this means that a bunch of native views, like keyboards and third-party SDKs that might have native views, all of those get dark mode automatically, and if they support it. And last of all, there's this smooth transition on iOS, which is a really delightful user experience. But like any engineering decision, there are trade-offs. So here are some gotchas with platform color. It does add some native complexity. So with the traditional example, everything was kind of laid out in the React component, so you can really easily understand what's going on. Here, that complexity is kind of hidden away in this mysterious color object that people. Platform color itself is relatively new, even though it came out quite a few versions ago. But there were still bug fixes up till as recently as React Native 70. So be aware of that. This might be a big one for some, but on Android, you do require an activity restart. That's just kind of how dark mode works natively on Android. So, and because React Native is a single activity app, in most cases, it would require restarting the app. And you might have to write some native code, which might be a pro or a con, depending on who you are. So let's summarize a little bit. To implement dark mode at scale, here are some of our learnings. First of all, implement an app-level theme override. This allows you to do gradual rollouts or internal or alpha testing without affecting the rest of your users. This also allows you to do gradual rollouts and A/B test dark mode even if you wanted to. The second is to tokenize your colors, which you should kind of be doing whether or not you're implementing dark mode, and preferably by usage. And last of all, check out the platform color API. It's pretty cool. So I did put together a quick example of platform color in case you wanted to check it out. Here is a link to the GitHub repo. And I managed to put together this demo with Expo config plugins, so you could define those colors within the app.json configuration. And if you run the pre-build, it's going to generate all those colors natively. So it's a pretty cool example, so definitely check it out. So yeah, I hope you learned something today. We're super excited about dark mode and getting that to our users and hopefully getting those 2 stars back. So thank you very much.
Hi, everyone. This test is about Maestro and testing at Yonder. And you can find me on Twitter at Henry Moulton. And as Eli said, if you're a Londoner, you might want to go check out yondercard.com. So I'm Henry. I used to do freelance contract React Native, and today I lead mobile development at Yonder. You can find me at Henry Moulton for React tweets. And how I got into React Native. So I actually started with something that wasn't React Native. Back in 2015, I was in Silicon Valley for the summer as a student, working on an app. And Ionic was the first mobile cross-platform tool that had a really great developer experience. Sadly, it did not live up to the promise of create amazing apps. It used HTML5 web views, and a year later, I then came across this thing called Exponent, now Expo. Build native apps in JS that just works across iOS and Android. The idea of cross-platform being obvious just stuck in my head. And even now in 2023, we're still in this duopoly of iOS and Android. And I'd just like to shout out, back then, 2016, I'd sort of come from that Angular world, and I really didn't know too much React. So it's a little shout out to Brent, Charlie, and Joanne, all members of the Expo team still today, for being helpful back then. If they weren't, I'm really not too sure to be standing here today. So there's 3 parts to this talk: testing at Yonder, Maestro, and a little bit about ideas for testing in the future. So section 1, testing at Yonder. So just to set the context, what is Yonder? Yonder is a new fintech startup. So we're going to have unique sort of testing constraints. We're in fintech, so we're regulated, so we've sort of got to be doing a bit of testing. We're also startups, so we want to be able to move fast. Although started in 2021, we are not buy now, pay later, cryptocurrency, Web3, or part of the metaverse. Our first product is a rewards credit card. You spend £210 at Airbnb, you get 210 points. £1, 1 point. And then for every pound you spend, you can rack up those points to spend on restaurants and bars and experiences across London. For example, Cricket is a really great Indian food restaurant in London. And let's say you had racked up 3,500 points, would cover your entire meal and drinks for up to £100. And to give you a bit more about the timeline of how we developed it, Tim, Thiso, and Harry, the co-founders of Yonder, started in early 2021. And then myself, a backend engineer, a designer, and a marketing guy called Tom joins the team in June. We have our first prototype card done by October, and then we launched in February 2022. Yonder's initial sort of proposition is quite a premium card. If you've come across like an Amex Gold, or maybe in the US, a Chase Sapphire Reserved. But we're going to be launching multiple products over the lifetime. We're happy to announce we've just raised our Series A. TechCrunch called us Amex meets Secret NYC for Gen Z. I'm not too sure what that means. But I can tell you, at Yonder, we're really committed to making really, really great React Native apps. So section 2, Maestro. So this is really split into 2 bits. What testing was I doing before Maestro? And then, as a result of that, why do I bet on Maestro today? So when I joined Yonder, the only design, I didn't have any screens. I only had this flowchart. We hadn't really figured out the product at all. All we knew is there'd be a credit card flow sign up. And this is actually the most, it's far, far more complicated now. But I'd just left Amazon, where I'd be doing some Appium and end-to-end there. And it was a really big transition going back to an early stage startup. Why is that? The reality is most startups die. I spent the last 2 years thinking about testing for a fintech startup that wants to safely move quickly, but could die. And just for some context, at the time before we raised Series A, which we announced just a few weeks ago, it was actually really hard to get that done. Only about 30% of founders who raise a seed round will go on to raise an A. And so I was sort of in the situation where you probably can't be a financial app with some tests. Shout out to Katie's talk on payments, where he's sort of saying, you sort of have to have tests for this stuff. But no startup succeeds because it has tests. They succeed because they find a great product and a great market that wants that product. And so when I was sort of devising a bit of a strategy, I came back to this banger of an old tweet: write tests, not too many, mostly integration. And that sort of led to 3 rules for testing at Yonder. We sort of write the tests as requirements, so this is called outside-in testing. We don't isolate code during testing. So concretely for UI, this is a bit surprising, but what we actually do, any sort of integration test, we render the entire app using React Native testing libraries you're about to see. And we only use mocks for our external systems. So concretely for UI, that's often the API server state that you're going to render some UI from. So when we're starting a new feature, we'll often sit down with Craig, the designer, and myself, and maybe a backend engineer, and just think about the feature holistically and say, hey, what are the tests that's sort of the requirements for this feature? And then when we go into writing one, you can see we're sort of setting up that API endpoint with a mock server at the top. We're rendering everything with that sort of render app helper. And then we're using Jest and React Native testing library in this sort of fashion of what I call sort of like headless end-to-end. And then doing some assertions as a result of that. And actually last year, I was sort of in this situation where I was using GitHub Actions 8 GB runners. And I was in this situation where rendering lots of React Tree in RAM, in Jest, is really RAM hungry. And what I've sort of found is that those little 8 GB runners sort of flake. And so actually my tip is, if you do go down this route, self-host using a super high RAM CI machine. About, anecdotally for us right now, 2 years in, 128 gigabytes of RAM is ideal. You don't have to use AWS, GCP. You can just buy a machine or just get a dedicated server, set up GitHub self-hosted runner, and just use that. And then as a result of that, you just get all of your tests running in less than a minute. But I mean, end-to-end testing was still on my mind and still is today. Thanks to Johnny Berger, who's speaking next. He actually managed to get hold of Coinbase's apps package JSON. You can sort of see, like, it's really clear, if you're an established app in the React Native ecosystem, you're probably using something like Detox or Appium to do a bit of end-to-end testing. But having done that in the past, I just always came to the conclusion, the tooling just hasn't been good. And actually, interestingly, that seems to be, if I were to bet, the case also in the native world. Here's an excerpt from a primer on automated mobile testing, which is a really great article I recommend checking out. But it says it's from an ex-Uber engineer. At Uber, for instance, we only had a handful of UI tests for many years. Similarly, Airbnb, Robinhood, and Shopify have invested heavily in unit and screenshot testing, but have only a small number of UI tests. And I mean, maybe you're not familiar with these tools, but if you are, how does Detox and Appium, when you use them, make you feel? To borrow a bit from Inside Out's, the film from Disney Pixar, what sort of emotions are you sort of feeling here? Because you know what you want. You just want green ticks in your CI. But at the moment, speaking to engineers, listening to people's experiences on podcasts, and coming to conferences and talking about it, what you end up getting is setup time, sometimes a week, to just get Appium running, flakiness, weird selectors, breaking on library and React Native upgrades, no first-class CI infrastructure, a bit like ES build, and bad Expo support. So, if you're lucky, you're feeling a little sad, but sometimes you just feel that flakiness and you're just like, ah. Why do I bet on Maestro? So what is Maestro? It's an end-to-end testing framework for mobile.dev. It's growing with the community. It's 8 months old. And it started by Leland, who led mobile platform at Uber. They actually started mobile.dev. It's sort of an interesting story. They started focused on performance testing. And they built this sort of end-to-end testing product to enable for performance monitoring. So you would sort of click through your app, measure the performance, not too dissimilar from Alex's previous talk. And they showed it to customers. And then all the customers sort of said, actually, it's the end-to-end tool that we really want. They're new, but they're ambitious. They really call themselves the next era of testing. And I spoke to some of the Maestro team, and there's some really cool stuff that they're going to work on in the future that they're happy to share that's on their mind. For a while, for the last few years, we've sort of seen in the React Native ecosystem, there's maybe like a screenshot testing tool or a performance monitoring tool, and they're sort of fragmented. They have different dependencies. They have different maintainers. But as we've sort of seen with Expo, sometimes it's really nice for a company to just say, hey, we're going to handle all of it. And they also have big ambitions to be a platform for mobile too, mentioning things like feature flags. But when it comes to Maestro, what I love about it, it's simple. Anyone can write Maestro tests. Writing these tests is as simple as using your app, which I'm about to show you in a second, which means your designer, PM, QA, or even your mum could write them. So we're just going to jump into the demo. So here we can see I'm just typing in Maestro Studio. I've got my simulator up on the right-hand side, and it's going to open a web browser. And then on the left-hand side, you can see I've got a sort of representation of my simulator with the entire view hierarchy I'm able to look at. And I'm just going to drop in the Wikipedia app. So one thing that's really great about Maestro, if you start using it, is they give you sample demos that you can quickly use to get going. And so I'm just going to show you how easy it is to get started writing a test using Maestro. So you can click around in the inspector on the left-hand side to get the pieces of the UI that you want to tap on. So you can click skip, and it's going to skip through that. And we're just going to be focused on writing a test that searches for React Native, and then saves it, and then checks that it's saved. So I'm going to tap on search. I'm going to tap on my text input. And then I'm going to input text using the input text command. And then I'm going to tap on the first result. Interesting here, if you notice that, there's a tap on point. So you do get that ability to tap on specific areas of the screen if you don't have an ID. I wouldn't recommend that usually, but it's just for an illustration of you being able to prototype quite quickly, just get something working. And then you can tap on Save for Later, and then you can head back, and then it's going to head back to the main screen, go to the Saved tab, exit out of the modal, and then assert that React Native text is visible in that tab, in that screen. And that's it. And then you can bundle all those up and export them. It gives you the code straight away. And you can take that, you can copy and paste that into your IDE, start working on the test again, or you can just save that YAML file, and then maybe you can commit that, send that over, something like that. So just going to jump back to the presentation. So yeah, so maybe you've got your test now that you've had written out. Maybe it's done by a QA, and you can put that, and you can commit that, and you can run it locally. But they've also, similar to EAS builds, they're also investing really heavily in their own cloud solution. And similarly, I really like embracing when I don't have to figure out CI stuff. I'm a mobile developer. As much as I've, in the past, bought Mac Minis to set them up to run detox tests and do the whole thing and save to GitHub Actions, it's not something I really want to be maintaining. And the panel that they have there lets you see recording straight away. It gives you the commands, hierarchy, and logs, all really out of the box. You can set up it using GitHub Actions to automatically run. You can actually also pipe your EAS build outputs to Maestro. And the question is it a game changer? It's simple to write. It's easy to execute. They have a great, passionate team behind it, an active community. And while they're still early in their mission, I think they're really focused on getting there. If anything, it really reminds me about Exponent back in 2016. They're committed to the cause, and I think they're going to go on to do really good things. So section 3, just some ideas about testing. So, coming from startups, I'm still really aware of this sort of on the other end of the spectrum, right? As a piece of software becomes more mature and relied on, the value of its tests increases. And there's some extreme examples where actually maybe the test code is more valuable than the application code. So maybe you've heard of SQLite, and maybe you've used it from Expo, and there's also a JSI version with React Native Quick SQLite. An interesting fact about SQLite, it has 608 times as much test code and test scripts than application code. 608 times. But it has to be relied on airplanes. If you have a crash, SQLite is deployed to everywhere, by the way. It's on everyone's mobile phones. It's on probably toasters and fridges. But it's also relied on by Airbus for airplane control. And it's a bit, a mobile crash on your phone is, maybe a 1-star review, but an airplane crash is a disaster. So idea number 2, when writing recordable tests becomes simple, your tests can become part of your app's requirements and specification. Tests can be the start of your new iteration. You can sort of write out, even your designer could write out your test and say, hey, I think it should be doing this. And then it's up to you, maybe you work together on that, and then you go on and iterate, you use the Figma documentation, so you use your Figma designs to complete that. And then later, once you've shipped that feature, you can then use those screen recordings as demos and docs, your whole organization to, as you expand your product over time, to understand all those small little niche features that aren't often used, and you often think, hey, how does that work again? And you can potentially also, if this stuff gets good enough, just say, hey, if this end-to-end test passed, it's done. We'll mark it as completed in Linear or Jira or whatever you're using. And I just think there's a lot of potential here. Third idea. When it's easy to pull in code from libraries and AI, it makes tests more important. So, it's been a really wild sort of 6-8 months with ChatGPT and Copilot. But I've sort of come to this sort of conclusion or thought that when code is generated, it really makes tests become more important during the review process. And tests might become a really important part. If we're thinking about like ChatGPT v5, v10, wherever this goes, tests might become a really important part of ensuring that AI is aligned with the requirements of that code it's meant to be generating. And so, thinking a few years down the line, does writing the correct test become the most important part of our jobs? And does the specification become the product? Thank you so much.
Hi, everyone. I'm so happy to be here again in beautiful Krakow. I've had a blast for the past 2 days. I hope you did too. And I hope you still have a bit of energy before the next break, because I got a lot of cool things to show off. I'm Alex. I've worked at BAM for the past 7 years, developing mobile apps in React Native mostly. And I specialize in mobile apps performance. And if you know me, you know that I often tell this story of we had a client a while ago coming to us, contracting us to build a mobile app and a web app sharing code. Well, if you've been following this conference, you know that, yeah, this is what we do, right? So we thought, super cool. What was really interesting about this client was that they had a lot of technical standards, which was really nice. And specifically on the subject of performance, on the web, they told us this metric that we should have, that our lighthouse scores on all of the web pages should be over 90. So if you don't know what lighthouse is, I Googled it the other day, and apparently it's a movie starring Robert Pattinson and Willem Dafoe. So, Google doesn't know me at all, evidently. This is a screenshot from my actual phone. No, the one I'm talking about is this one. You go to Google Chrome. You can get on any web page, basically click a button, and instantly you get a performance report. For funsies, tried it out with Google.com. Ironically, the score was only 80 out of 100, which I thought was ironic because, Lighthouse is also from Google. But anyway, client's requirement on the web, Lighthouse score over 90. That's a nice metric to follow. On the app, they just told us the app should not lag. Period. So I thought, OK, how can we actually measure scientifically that the app is not lagging? So I turned to Google for answers, because ChatGPT not a thing at the time. And I came across this gold standard by Google that the app should run at 60 FPS. Actually, more for certain devices. Because an app is basically like a movie. It's animated pictures. If you scroll through Instagram, the app is going to be responsible to draw 60 images per second of your screen going up to give you an impression of smooth scrolling. But is that enough? Well, you've heard William call it le nerf de la guerre. Of course, some other metrics like the JS thread usage come into play if we're React Native developers. For example, here I have an app, beautifully designed, I must say, with a kill.js button that runs like very expensive calculation on the JS thread. So of course, if I click it, then I can click me, nothing happens until kill.js finishes, and then poof, OK, it works. So we need to take that into account as well. And if you were here last year, you know that I presented the Performance Monitor Flipper plugin that takes both of these into the account, JS, and UI, and at the end of it, gives you a performance score for what you're doing in the app when you were measuring. I think this was already pretty cool, and we got a lot of nice feedback on it. But how far are we actually from the Lighthouse dream? So Lighthouse, you can actually take any app and measure its performance. Here, we do have to install the Flipper plugin. Also, we can only measure debug apps, because well, you don't want to have Flipper in production, actually. And to be honest, it's kind of limited. It just checks UI and JS FPS. It doesn't really embrace everything that can happen to check the impact of big changes, like, oh, if you're switching to new architecture, for example, how do you know if your performance is better or worse? The question is, can we do better? Well, today, I am very thrilled to present to you the new project we've been working on, which is called Flashlight. The joke being that Flashlight is kind of like a pocket lighthouse, so like a mobile lighthouse, so suitable for a lighthouse for mobile apps. So let me show you a quick demo. The quickest way to use it is actually via a Flipper plugin. You can also use it via CLI quite easily. Let me reduce this view here. And so here's my real phone that I'm sharing. And let's say I have yet another beautifully designed app, example app, with two fantastic buttons. I did not install anything on the app. I can just open the Flashlight plugin, click Auto Detect here, hit Start Measuring, and instantly, I'm going to get a performance score on my app, which will actually depend on what I do. So for example, if I click Kill.js, of course, my score is going down. I can see my frame rate also. So if I click Kill UI, actually, my phone is quite good, so I have to really kill the UI to make the FPS really go down. Of course, I'm killing the UI thread, so the FPS is going down. But I also get a bunch of other metrics, like CPU usage and CPU usage per thread. For example, this is the JS thread, so if I click Kill.js, I can see the JS thread CPU usage going much higher. Basically, with the previous plugin, you had 0 JS FPS. This is what you wanted to avoid. Here, you need to avoid the CPU going to 100, because this means the app will be unresponsive. You also get RAM usage, and actually you can even inspect all the threads that you have in your app, which might be useful. For example, here we have the UI thread again when I click the button. So already, I think this is pretty cool. We have a nice improvement over the previous plugin. I don't need to install anything. I got a lot of other metrics for my app, but it doesn't really stop there, because basically, I can test any app with that. They can be in debug. They can be in production. They don't even have to be in React Native. I don't even have to own them. For example, I could go ahead and measure scrolling performance of Twitter, which is actually pretty good because, well, my device is pretty good. But, might want to compare performance between Twitter and Blue Sky, for science. This would be one of the ways to do it. All right, so this is Flashlight. It's worth noting that it only works on Android so far. If you do want to have iOS support for it, you can voice it on the GitHub repository. There's an issue actually detailing it, but it's worth noting that there's a massive performance difference between the most sold iPhone. This was the most sold iPhone in France in 2021. Basically, it can actually run JavaScript 10 times as fast as the most sold Android phone in France in 2021, according to geekbench.com. So this is why we focus a bit more on Android. All right, but if you were here last year, you know that I talked about one thing, and this is the fact that performance measures are not deterministic. So, if you measure your app startup time, maybe at some point it's going to be 4 seconds, and the next time it's going to be 3.9. And you'll be like, oh, I shaved off 0.1 second. Hey, maybe it's just randomness. You don't really know that. So last year I said, to make your measures as deterministic as possible, there's a few things we can do. Average your measures over several iterations. As much as possible, keep the same conditions, network, etc., for every measure, and automate the behavior you want to test. But dang it, isn't that just annoying and time-consuming, right? Well, luckily, I'm really happy to tell you that Flashlight also got you covered, because via the CLI, you have the Flashlight test comment. How it works, basically, is you can pass any end-to-end test, or even ADB comment that does stuff in your app. And if you were like, oh, end-to-end test, that sounds really annoying to do, actually, you can check out Henry's talk next. You might be in for a surprise. And essentially, Flashlight test, what it's going to do is it's going to run your end-to-end test several times. It's going to gather performance metrics and output them in a JSON file. Basically, yeah, kind of an ugly JSON file. But there is then actually a comment that you can use on the CLI to actually open this JS file and have your report just like you would have in Flipper. So here, we were actually measuring scrolling performance in one of our apps that was using a flat list. And it was pretty terrible, score 3 out of 100. So what did we do to improve it? Well, we switched flat list for flash list. A lot of fla. And so we reran the test with the newly updated APK with flash list and got another JSON of measures. But what's really nice is that to easily check the impact of the change, you can actually run Flashlight report with your first JSON of measures and your second JSON of measures, and you actually get a report with a comparison. We had a lot of heavy UI components, so flash list was much better. What I really like is that, yeah, you have the graphs with neat colors, and you can easily see that, for example, CPU usage is just much better for flash list in yellow than it is for flat list in blue here. It's worth noting that there's actually no correlation between Flashlight and flash list, except, well, a lot of letters. And yeah, the fact that using flash list tend to make your flashlight score go up. All right, but can we do better? Because if you think about it, well, Lighthouse, it was, the promise was simple. You take any website, you pass it, and boom, performance score. Wouldn't it be nice if we could just take any app, pass it to something, and get a performance score? Well, I'm very happy today, this is what I'm actually most thrilled about today, to present to you Flashlight.dev. And let me show you how it works. So essentially, Flashlight.dev, let me just increase this. Flashlight.dev is a website where you can just drag and drop your APK. So here I have a sample React Native app. Let's see what it looks like. It's just a basic Twitter clone in React Native. And the only thing I need to do, so Wi-Fi is a bit slow, but don't worry, I got the report. We'll skip to the end of it probably. But the only thing that you need to do to get your time to interactive is here to say what text will appear in the app when it has finished loaded. So for example, here when the app is loaded, it will display Dojo Wordle here. So I'll just put it here. And when the APK has finished uploading, I can just click Send me my performance report. Then what's going to happen is basically Flashlight is going to run the test command in the cloud for you, outputting a bunch of logs like this, running 10 iterations of your test. So it's going to be starting the app, waiting for something to be visible, Dojo Wordle, and then gather performance metrics. So at the end of it, you will be able to automatically get the performance report like this. Just by drag and dropping the APK, filling in an input, clicking submit, waiting 10 minutes, boom, you have it. What's really cool about this as well is, well, you get all the same metrics. And one of the features that were widely asked for when we were in private beta is that you can actually check on the graphs, and the video of the test actually follows. So for example, here you might be wondering, what is this peak CPU usage? Well, of course, here, like, the app is starting and we're displaying stuff, so this is why this is happening. It's worth noting as well that since this is running 10 iterations, we can also see each iterations individually and go through them. But we default to showing just the average. So I feel like with Flashlight.dev, we're coming really, really close to the Lighthouse dream. And I'm really happy to say that it is actually now in public beta. So you can all go to flashlight.dev, basically upload your APK, and it's totally free, at least for now, while we can pay the bills, because we're actually running those on a real device in the cloud. And you can get your performance score. Can we do... Can we do even better? Because you might be thinking, like, OK, this is cool, but I only have, like, startup performance. What if I need to, like, just log in on my app to just display the score and everything? What if I want to do something else in my app, like testing scrolling performance? Well, we also have the Flashlight Cloud comment. So you can actually use it on CLI, upload an APK, upload a Maestro test, and you can basically measure the performance of anything you would do on your app in the cloud. And it's actually quite easy to integrate with any CI, and we particularly love EAS. So we have a doc to actually add an EAS hook to your app so that every time you submit to production, for example, you get your performance score. All right, but one last thing. Who of you will have the best Flashlight score? Because I'd like to introduce the Flashlight launch contest, starting now and until next week. Basically, to get a nice prize, all you need to do is go to flashlight.dev, get your app stat score, just tweet at BAMLab and share a screenshot of your Flashlight report, and your app also preferably. And we'll publish the top scores next week, and the top score will actually receive a cool prize. Just a few conditions, though. Your app should be on the Play Store with over 100 downloads, because otherwise, you could just like init a new Expo project and probably get 100 out of 100 score. That would be maybe too easy. That would be smart to do, sure. And also, please fill the what text will appear field. You don't need to fill it to get your actual score, but it's nice to get the TTI. All right. Actually, I have a little bit of time left. That's amazing. So I'll actually switch to some slides that I didn't think I would be able to do. It's all the things we want to do next, because actually, we're very eager to hear about your feedback. But like I said, one thing that Flashlight cannot do is explore the app on its own. So we actually want to be experimenting with app auto-exploration so that you just have to drag and drop your app, and actually Flashlight would be able to tell you if your performance is actually good or not. We also want to be adding more metrics. We think battery life, for example, is a very important metric to be having. And network also could be cool. And yeah, deal a bit more with stats, because average, if you have doubled a bit with stats, you know that it's not necessarily the best thing. But yeah, in any case, let us definitely know what you think. And all right, yeah, that's pretty much it for it. Go to Flashlight Dev, get your performance score. I will be...
Good to be here. Good to be here at App.js to talk to you about the long tail of type safety. So I'm Simon. I'm a software engineer. I'm a founder. I live in the Bay Area. I've been at a bunch of big tech companies. I've built a lot of things in React Native. And in this particular case, though, I'm going to talk to you more about TypeScript than about React Native. And so a lot of folks use TypeScript, right? Especially React engineers, React Native engineers. And TypeScript is great. We get a lot of confidence in our code. We get worry-free refactoring. We get nice autocomplete in our editor. And ideally, we get fewer runtime exceptions, right? The idea, or the dream, is that we never have to see this again. We never have to see an uncaught exception. Undefined is not a function is kind of a famous one, but really any uncaught exception in our browser console, in our production code. And so the thing is, though, TypeScript is not, out of the box anyway, right, is not type safe. And what I mean by that isn't just that there are some escape hatches, which there are, right? It's not just that you can use things like any and make it not type safe, but even with all of the strictest options turned on, even if you don't use the escape hatches, it's really not a sound type system. It's not fully sound. And I'll use this example to sort of illustrate that. And this looks pretty safe, right? So here we have an array of strings, and we're going to have we're going to create a variable with a type that says, okay, here we have an array that can take string or number, and we're going to assign an array of strings to it. Since string can fit into that array just fine, seems legit, right? But we have to remember that JavaScript is mutable, or arrays are mutable in JavaScript. So as soon as we push something onto that array, we now have a number in our strings array, which is not type safe. And that, of course, could blow up at runtime, and TypeScript won't catch this, right? TypeScript doesn't really have any opinion about this code. It's totally fine. This passes. And you might think to yourself, this is really an edge case that I don't need to care about, right? Like, I mean, who does this sort of stuff? And if you do, maybe you deserve a runtime exception. But no, that's not true. I think the reason I show that example really isn't just because it's some edge case that I think you need to lose sleep over. It's because there's a fundamental design choice that is illustrated by this, right? And it's that TypeScript really intends to be pragmatic over being sound. Like, TypeScript doesn't claim to be sound. It doesn't. It's not a core design decision of the language to be perfectly flawless in terms of type safety. But we're all here to learn about type safety, so we want to maximize type safety. We want to get a little bit more soundness out of TypeScript, at least as much as is reasonable, as much as possible. And why? Well, for all the reasons that we looked at earlier, right? We want that confidence in our code, and of course, most importantly, we want fewer runtime exceptions. So where does TypeScript fall short? Where can we kind of pick things up and get and kind of squeeze more type safety out of the type system? So TypeScript is not null safe out of the box, which is unfortunate, but we can get most of the way there. It is there's a lot of, I call them escape hatches, but there's a lot of ways to kind of do things that you shouldn't be doing, right? Type assertion is a good example, using the word as. And of course, as const is good, but every other type of as is not good, generally speaking. And there's no built-in mechanisms really for validating data that comes from outside of your code, right? Data that TypeScript can't possibly know about because it doesn't exist at compile time. So what can we do about it? Well, I've kind of put it into broadly 4 categories, right? So we can tweak our config, we can get better, we can use lint to try to avoid some of the bad things that we probably shouldn't be doing. We can do some stuff with global types that I'll show you in a minute, and we can do some stuff around the I/O boundaries, which I think is really important. So start with the easy stuff, stricter config. I think the first one here is a no-brainer. Strict is true, and what does that mean? That's a flag that will turn on a whole family of strict mode options, and it's all of these things that I don't think you need to care individually about these, right? You just turn on strict mode, and you get all of these strictness rules, which is great. But the second one on this list here, the no unchecked index access, I think is really important. And so, to put it in someone else's words, no unchecked index access is the most awesome config option that you've never heard of, right? And it's a little unfortunate that it is very rarely used. It's been around for a few years, but I'll show you an example of what is this strictness rule and maybe why you should turn it on. So most of you could look at this code and be like, well, that's going to fail, right? That's going to blow up in production. And TypeScript is like, nope, that checks out. You told me you have an array of strings. We can call to uppercase on a string. No issue there. And this is kind of the object variant of that, right? It's like, here's a record that has strings in it, so TypeScript will let this fly. And we want to turn on the no unchecked index access, typically just to kind of make sure that stuff like this doesn't creep into our code base. And I'll use a sort of anecdotal example. And so this top line is real code that I saw in a code base, and I'm doing the code review, and I was like, well, why would we use .filter and then use and then get element 0 when we have .find? And it turns out the response was, oh, because .find might return undefined, but the first one will not return undefined. And so that is unfortunately not the case. But TypeScript will allow you to do it, right? TypeScript will let you get away with the first one and say, yep, for sure that's going to be a user coming out of there. So we don't want stuff like this in our code, so we can get the rules a little stricter. Okay, lint rules. Why are we talking about linting at a TypeScript talk? Because TypeScript has escape hatches. And some of the escape hatches are really useful, right? They're things that we want to use, that we need sometimes, right? There's certain times where just like you have to bail out of the type checker. But arguably, you shouldn't reach for them unless you really need it. And so we can use lint rules to help us, prevent us from using some of these escape hatches, right? Using any is kind of the obvious one, right? Everybody kind of knows any is bad. We have unknown, which is the type safe variant of that. Type assertions, I think folks, especially more junior engineers, don't realize that a type assertion, when you say like X as user, doesn't convert anything to a user, right? It's really just telling the type system, hey, I'm going to override your opinion about this and tell you what this thing should be. Non-null assertion, you might not have heard of this one, and if you haven't, great, because it's a little bit type unsafe and probably good to avoid. And then we have these kind of strange types that you don't see super often, but like function with a capital F. If you type a function as function with a capital F, it'll let you do things that you probably shouldn't be doing. We have better types to do that. So that's where our linting tools come in, and we can it's really easy. We pull in TypeScript ESLint, which I'm sure many of you have in your code base, and you turn on the recommended config, or if you're brave, you turn on the strict preset, and you're off to the races, right? These are the low-hanging fruit, right? This is not crazy, complicated stuff, and then you get the warnings, and it says, don't use any. Now, you can still manually override that. You can disable that if you really need the escape hatch. But I think as a whole, it helps us with our goal, which is to make sure that we have strictness, type safety as a priority in our code base, right? Or the non-null assertion operator, again, like we don't want to be using that. So, okay, better global types. So this is interesting, I think. Typically, you'll see code like this, and TypeScript won't complain because TypeScript doesn't know what came out of JSON.parse, right? It has no idea. And we could try to tell it that, hey, this is an object of a particular shape, but out of the box, JSON.parse will return any. And as we learned, any is really not awesome. And so maybe the takeaway from this is that even if we didn't explicitly write the word any's can creep into our code base pretty easily. And JSON.parse is just kind of, for historical reasons, probably should return unknown, but it returns any, and then TypeScript allows us to do things like this that we shouldn't do. So how do we fix it? We open our global.d.ts file, and we have to paste in some magic code that overrides the built-in type defs for this function, and we say, okay, we don't want any, we want unknown returned, and if we do that, then I don't have the slide for it, but it'll show us an error. Right. So that's a simple one. What about array.isArray? Right. So array.isArray is a nice, helpful sort of type guard that will let us know that, TypeScript can be sure that after this line here that we have an array, but an array of what? Right. TypeScript has no way of knowing what it is, and so it defaults to any. We probably don't want that. We can override that again in the global.d.ts. But like as you can see, the list is going to start to get long. Like how many of these are we going to do, right? And so the answer is the community kind of comes to the rescue and provides, or at least there is this new package that I think is really cool called TS Reset. It kind of fixes a lot of the type unsafe things that are kind of in the built-in type defs, right? Okay. So what happens then? You try to parse something, you call something that doesn't exist, you get an error, and all is good, right? The result is of type unknown. Can't call these methods and properties on unknown. Okay. So now we get to kind of what I think is the more interesting sorts of problems, right? Because like everything so far, it's like, hey, add a config change and drop an npm package of some sort in. But I think here's where things get interesting, right? So our application has I/O boundaries. It has data. It has things that are coming in from the outside world that TypeScript can't possibly know about at compile time, right? And so a typical example of that would be something coming in from the database, but it could be user input, really anything that comes from JSON. We saw a lot of JSON examples. Route params is something that you don't often think about, right? So you might say, use, what is it, use router, use route, and then .params .username and expect it to be there. And so anything that is happening at runtime, TypeScript can't know about it. So what are we going to do about this stuff? So I'll use this example here. And this is from a Node.js backend. I think this is kind of like one of the examples from their website. We try to get some data from request.body. And it's not just that TypeScript doesn't know what request.body is. It's that we can't even know, right? There's no way to know what will be in request.body because it's whatever the user sent us in an HTTP request. So there's like not a great solution to this out of the box. And so you'll see code like this all over, and that of course will break at runtime if you're not careful. But TypeScript won't complain. TypeScript will be totally fine with this. A more kind of React Native example is like async storage. You pull something out of there, you parse it, you expect these fields to exist, and you might have a little more certainty here because presumably we're the ones who put it into the async storage. But again, there's really no guarantees here in place at all. So what is the solution? The solution is validation, which is probably obvious. And there's some great validation libraries. So this is one of the more popular ones. It's kind of TypeScript aware, and I'll show you an example of that. So here. We can just define a schema. We can say, okay, this is what a user looks like. It has this field that's a string. It has this other field that's a string. And then, we use this schema to validate, right? And so this is an example of using safe parse. It has various different methods on it. But here we can say, all right, well, we're not just going to take that data and blindly destructure it. We're going to run it through some validation logic. And what's cool about this is that because it's TypeScript aware, it'll force us here to handle the unhappy path, right? Like we must handle the result.success or else TypeScript will complain, which is really nice. And once we've handled that case, then we can be certain that it has validated and it's fully type safe. So I think generally speaking, a lot of the problems that kind of fall into this category of kind of I/O boundary stuff can be solved with schema-based validation, right? So essentially Zod or one of the other similar libraries is the solution to a lot of the kind of untype safe stuff that TypeScript doesn't really give us solutions for out of the box. So the fetch problem. And this is really another kind of extension of the pattern that you're seeing kind of over and over here. But we're going to fetch something from a remote server, and we might be like fairly confident that it's going to send us back some JSON data that has a movies property, and so we'll just go ahead and loop over it and render some movies, right? The issue is that any number of things could go wrong and we don't get back what we expect, and there's no type safety here, right? We wouldn't get any autocomplete. TypeScript wouldn't know what's in this array, what's in this movies array, and so what would we typically do? Well, we'd probably just use a type assertion, right? We'd say as, response body, and we'd write the type for that somewhere and say, okay, well, response body is going to have a property called movies, which has an array, and of course we have to write the type for movie as well. And so this is kind of clunky, and it sucks a little bit, and as we learned earlier, as is not ideal. We'd like to avoid it. So what can we do? Well, if you are lucky enough that your API has open API specification of some sort, then you just run it through a tool, and there's several tools. I'm using this as an example because I've used this in the past, but you generate your TypeScript defs, your TypeScript types, your interfaces, and works really nice if your endpoint, if your server supports that, and then you still have some boilerplate because you're like, okay, well, I'm going to pull out of my generated schema. I'm going to get the /movies, but I want the response for the get. That's the 200. That's the application JSON, and whatever. It's a little boilerplatey, but at least we didn't have to write all the types and try to keep them in sync with the server, right? Or we could take it a step further and use a fetch client that kind of understands the generated types, and then you can just say, I'll show a better example here. Then you can just say, okay, well, I'm going to make a post request, and TypeScript is now going to force you to provide the right fields that the post request is expecting, and similarly with the data that you get back. So this is an example of where the community comes in and says, okay, well, we can generate types based on some specification. We can even generate a client, an HTTP client, based on that. So, of course, if you're using GraphQL, you don't really have to think about this as much, right? GraphQL libraries are no stranger to type generation, and so if you're using GraphQL, you're probably in a great position with that, right? You don't have to think as much about it. You don't have to care about as much about that. And if you're using tRPC, even better. You don't even have to think about type gen, right? tRPC is this really cool type-safe way of just calling functions on your server. Now, so yeah, if you can use tRPC, absolutely go for it. The downside is you need to be running TypeScript on the server. You kind of need this mono repo set up. Like there's requirements that need to be in place. But okay, what is tRPC? Move fast and break nothing. End-to-end type-safe APIs. I think it's really useful. I think a lot of folks in the community have kind of rallied around building type-safe tooling like this, and that's great. Okay, so we only have a few minutes left, and I want to talk about routing and navigation. Okay, so everyone probably uses React Navigation, right? That's the thing to use. It's a good library. It does so much, right? It handles everything from gestures and animations and really complex navigation setups, and it's fantastic, right? Typically, you'd write some code that looks like this. You'd have you have some nice hooks you can pull in here. The downside is if you write code like this, in your editor, you're going to see stuff like this, right? You're going to see some red squigglies, and that's your editor trying to be helpful, or TypeScript trying to be helpful and say, well, I don't know if there's a username prop on this thing. We have no way of knowing that at compile time, right? We have no idea if there is a page called home that you can actually navigate to, or worse, you're going to see an error like this, which you're like, I don't even know what to do with that, right? So what do? Well, we go to the docs and we're like, what is the official way to add types? And you end up writing code like this, right? So you've got like root stack param list, and you've got all these kind of like utility types to essentially describe the, so you end up having to describe the navigation twice, right? Kind of one in the type system and then like another time in the, kind of JSX, right? So anyway, it works. This is the norm. This is the status quo. This is kind of what we do to make it all work. And what you end up probably with, so this is the, this is the solution to what we saw earlier, is that you have to add the angle brackets. This is just us telling TypeScript, hey, I'm really certain that because we're in the user profile component, this is going to be a user profile route prop, right? But that's essentially not much different than using a type assertion, right? And as we learned, whenever we're overriding the type system and saying, hey, look, I'm just going to promise you, I guarantee you it's of this type, right? That's, that's risky. And also, you're going to end up with like tons of code like this, right? So this is code that would probably sit somewhere in like a, in a types folder, and you'd have to describe all of your routes and everything. So anyway, it works. It's a little bit of boilerplate, but we get fairly decent type safety out of that. However, as many of you saw yesterday, we now have a better solution, right? So Expo Router has been around, but Expo Router v2 it actually has, like, it's type aware, right? It has type safety. And so, the reason I bring this up is not to say, okay, that was too much boilerplate, like rip out React Navigation and like immediately change technologies. That's not the right solution to everything. But I think this illustrates what's happening, which is that the community is kind of rallying behind good type safety and end-to-end type safety, and making sure that we can, not have to write the kind of code that you saw in this slide, which, like, this doesn't make TypeScript fun, right? None of us want to do this sort of thing. So anyway, I thought this was really cool. The community in all areas, but in this particular case, I think this is a great example of where type safety is becoming a priority. So the code we ship should be more type safe. Maybe this goes without saying, but the long tail of type safety is like handling all those edge cases, handling all the things that kind of TypeScript doesn't give us out of the box. And some of those things are simple, like adding a line to your tsconfig, or generating some types using some package off of npm. But I think there's a lot of opportunity, especially around the I/O boundaries. So that's my talk. This is me. The slides are at this QR code, and I really appreciate y'all sticking around talking about type safety with me. Thank you.
All right. Welcome back, everyone, from lunch. Today, we are going to talk about performance myths of React Native applications. So first of all, I want y'all to give kudos to yourself for showing up for talks after having a heavy lunch. So clap for yourself, please. And I want more cheers and energy in the room. There you go. Thank you so much for being a wonderful